We can make an algebraic fraction easier to integrate by splitting it into partial fractions. So here we have an algebraic fraction. We're going to split it into partial fractions and then integrate. We have 4 minus x over x plus 2 times x minus 1. And we're going to change it into the form something over x plus 2 plus something over x minus 1. To do that, we multiply through by the denominator, which will leave us 4 minus x equals a times x minus 1 plus b times x plus 2. Then we're going to find out what a and b are by substituting in values for x. So if we let x equal 1, we can get rid of a. What does that leave us if x is 1? So 4 minus 1 is 3. The a is going to disappear, 0 a's, and we've got 3 b's. So 3 equals 3b, b must be 1. If we let x equal negative 2, we can get rid of b. So 4 minus negative 2 is 6. And negative 2 take away 1 is negative 3. So negative 3a's. A has to be negative 2. So we can change a to negative 2 and b into 1. So we're going to integrate. I've switched them around. I'll write the b first. So 1 over x minus 1 minus 2 over x plus 2 with respect to x. When we're integrating a 1 over x, something to the power of negative 1, it becomes a log. And any constant in an integration, so the 1 or the 2 or the negative 2 even, they just stay the same. So this is going to integrate to give log x minus 1 minus 2 log x plus 2 and plus a c, plus a constant. One question for you to try. See if you can split it into partial fractions and then integrate. So we're going to start with our 5x plus 7 over x plus 1 times x plus 2. And we're going to change it into the form a over x plus 1 plus b over x plus 2. Multiply through by the denominator. That will give us a times x plus 2 plus b times x plus 1. Then if we let x equal negative 1, we will get 2 equals a. So a is 2. And if we let x equal negative 2, we will get negative 10 plus 7, so negative 3, equals negative b, so b must be 3. So we are going to be integrating 2 over x plus 1 plus 3 over x plus 2 with respect to x. So that would integrate to give 2 log x plus 1 plus 3 log x plus 2 plus a constant. Another question. This time we have to factorize the denominator first. So we're going to have 7x minus 2 over x plus 2, it's the difference of 2 squares, times x minus 2. We're going to write that in the form a over x plus 2 plus b over x minus 2. So the partial fractions, multiply through by the denominator. 7x minus 2 equals a times x minus 2 plus b times x plus 2. If we let x equal 2, we'll get 14 take away 2, 12. equals 4b, so b is 3, and let x equal negative 2, so negative 14 take away 2, negative 16 is negative 4a, so a is 4. So we're going to integrate 4 over x plus 2 plus 3 over x minus 2 with respect to x. And again, they're just 1 over x's. They become logs. So it's 4 log x plus 2 plus 3 log x minus 2 plus c. One for you to try. Pause the video, give it a go. So we want to factorize the denominator first. So 7x minus 10 over x times x minus 2. And we're going to rewrite it as a over x plus b over x minus 2. So 7x minus 10 equals a times x minus 2 plus b times x. We let x equal 2. We'll get 4 equals 2b. So b is 2. And if we let x equal 0, we'll get negative 10 equals negative 2a. So a is 5. We are integrating 5 over x plus 2 over x minus 2. So it's 5 log x plus 2 log x minus 2 plus c. And another question, we are going to split it into partial fractions again in order to integrate it. This time we have a squared term on our denominator. So we're going to have a over 2x plus 3 plus b over 2 minus x without the squared plus c over 2 minus x squared. So whenever we have one of our brackets squared in our denominator, we have the squared version and the not squared version in our partial fraction. So multiply through by the denominator again. We're going to get 5 minus 13x equals a times 2 minus x squared plus b times 2x plus 3 times 2 minus x plus c times 2x plus 3. So we can eliminate a and b by letting x equal 2. So we'll get 5 minus 26, so negative 21, equals 7c. So c is negative 3. If we let x equal minus 1/2, negative 3 over 2, we will get 5 minus 13, negative 3 over 2's, which is 49 over 2. And that will eliminate b and c. So for a, we'll have 2 minus 3 over 2 squared, so 49 over 4. So 49 over 4a. So a must be 2. We still need to find b, and we can do that by picking another value for x. So let x equal 0. We will get 5 equals 4 a's, and a is 2, so 8 plus, if x is 0, we'll get 3 times 2 times b, so 6b, and 3 c's, and c is negative 3, so 3 negative 3's are negative 9. So we get 6b equals 6. 6b equals 6. B must be 1. So what do we have to integrate? We're going to be integrating a, which was 2 over 2x plus 3, plus b, which was 1 over 2 minus x, plus c, which was negative 3 over 2 minus x squared. Now the first two are going to be logs. The last one hasn't got a power of negative 1. It's got a power of negative 2. So we can integrate that by reversing the chain rule. And let's go one at a time. So the first one, we're actually going to be integrating the logs by reversing the chain rule as well, because unlike the previous questions where we just had an x, here we've got the bracket differentiated is not going to be 1. So we're going to have to divide by the bracket differentiated. So that will be reversing the chain rule. And if we differentiate our answer, we should be able to get back to our fraction. So we're going to have 2 log 2x plus 3, but then divide by the bracket differentiated, which is 2. So it's just log 2x plus 3. And you can see it works by differentiating this. So it goes to 1 over 2x plus 3 times the bracket differentiated, which is 2. So 2 over 2x plus 3. The next one, we've got log 2 minus x. Divide by the bracket differentiated, which is negative 1. And our last one, so we've got negative 3 times 2 minus x to the power of negative 2. So add 1 to the power, that will become negative 1. Divide by the new power, so it will become a positive 3. But then divide by the bracket differentiated, it will become negative again. So it's negative 3 times 2 minus x to the power of negative 1 and plus a c on the end. And again, you can check by differentiating. If you differentiate each of these terms, you should be able to go back to our integrand. Okay, one for you to try. See if you can give it a go. So we have 8x plus 4 over 3x plus 1 times x plus 1 squared. That's going to become a over 3x plus 1 plus b over x plus 1 plus c over x plus 1 squared. Multiply through 8x plus 4 equals a times x plus 1 squared plus b times 3x plus 1 times x plus 1 plus c times 3x plus 1. Let x equal negative 1. We will get negative 4 equals negative 2c. So c is 2. Let x equal minus a third. So 8 times minus 1/3 plus 4 is 4/3. And that will be equal to 2/3 squared, which is 4/9 of a. So a is 3. And if we let x equal 0, we will get 4 equals a, which is 3, plus b, which we don't know, plus c, which is 2. So b must be a negative 1. So now we're ready to integrate. We're going to be integrating 3 over 3x plus 1 minus 1 over x plus 1 plus 2 x plus 1 to the power of negative 2. So let's integrate. We're going to get log 3x plus 1. So the 3 is going to be cancelled out. So when we differentiate log 3x plus 1, it's 1 over 3x plus 1 times 3x plus 1 differentiated, so times 3, which is 3 over 3x plus 1, minus log x plus 1. So this time the bracket differentiated to just 1, we can ignore it. And then our last one, it's reversing the chain rule. It's not a log. So add 1 to the power, goes to negative 1. Divide by the new power, so dividing by negative 1, same as timesing by negative 1. And then the bracket differentiated is 1. So dividing by 1 means it stays the same.